Managing databases isn't just a job. It's a high-stakes balancing act where every decision can tip the scale between uptime and chaos. Imagine this. One wrong move, one tiny mistake, and an entire system worth millions of dollars could come crashing down. That's the life of a database administrator. It's a constant battle against latency, corruption, and rogue queries that threaten to take down everything you've worked so hard to build. The pressure is insane, and the stakes couldn't be higher. You're the last line of defense, the silent guardian of the most critical digital asset in the world, data. Now I know what you're thinking. While you won't find masked guards or deadly playgrounds in your server room, the pressure, unpredictability, and need for precision might feel eerily familiar to a certain Korean thriller. Every day is a new game, a new challenge that tests your skills, your nerve, and your ability to think 5 steps ahead. The phone rings at 3 a.m. with a P1 incident. That's your red light, green light. A massive data migration is scheduled for the weekend. That's your tug of war. The consequences of failure might not be fatal, but they can be catastrophic for your career and your company. So, are you ready to play? Today, we're going to break down the 7 deadliest games every DBA faces in their career. I'm going to show you not just how to survive, but how to win. Let's explore the world of database administration through a Squid Game-inspired lens, minus the bloodshed, plus some real-world wisdom and command line magic. We're going to turn you from a nervous contestant into a master of the game. Stick with me, because this is the ultimate survival guide. Alright, first game. You're sitting at your desk, everything seems fine, the system is green. Suddenly, alerts start firing like crazy. The website is slowing down, users are complaining, and the whole application feels like it's stuck in mud. This is the DBA's red light, green light. One moment everything is running, the next it's completely frozen. The culprit? A single monstrous query that's gone rogue, consuming every last bit of CPU and memory. It's a silent killer, bringing your entire database to its knees, and you have seconds to figure out which query it is and stop it before the whole system crashes. This isn't just a hypothetical. This happens all the time. A developer pushes a small change with a seemingly innocent query, but it lacks the right index or has a catastrophic join. At a small scale, it works fine. But when it hits production with millions of rows, it explodes. It's like a ticking time bomb that just went off in the heart of your system. Panic sets in. Do you restart the server? Do you start killing processes randomly? No. Randomly guessing is how you get eliminated. You need a strategy, a tool that gives you X-ray vision into what the database is actually doing. This is where your secret weapon comes in. Explain, analyze. Before you even think about running a complex query in production, you run it with this command. It's like getting a blueprint of the game before it starts. It shows you the exact path the database will take to get your data, revealing every slow, inefficient step. It will scream at you, hey, you're trying to scan a billion-row table here. This one command separates the pros from the amateurs. It turns a deadly guessing game into a calculated strategic move, allowing you to pinpoint the bottleneck and fix it. But you can't just react. You have to be proactive. That's why we use monitoring tools like Prometheus, Grafana, or Datadog. These are your eyes in the sky, your guards watching the game. They track everything. Query times, CPU usage, memory pressure. You can set up alerts that scream at you the second a query starts acting suspiciously, long before your users even notice. You're not just waiting for the red light anymore. You're predicting it. You're optimizing. You're monitoring. And you're ensuring that your database always gets the green light. Congratulations, you survived the first game. But now you're thrown into your next challenge. The Legacy Labyrinth. You've just joined a new company and they hand you the keys to a database that's been around for 15 years. It's a tangled mess of inconsistent naming conventions, undocumented tables, and forgotten stored procedures. No one who built it still works there. It's a maze, a labyrinth, and somewhere deep inside is a minotaur in the form of a critical bug or a performance nightmare waiting to strike. Your job is to navigate this mess without getting lost or breaking something vital. This is one of the most terrifying situations for a DBA. You're afraid to touch anything because you have no idea what it might break. Tables are named things like data_final_2, temp_user_backup_new, and important_stuff. What does any of that even mean? Columns are cryptic, relationships are a mystery, and there's zero documentation. It's like being handed a map where all the street names are erased. One wrong turn, one deleted column you thought was unused, could bring down a feature that, unbeknownst to you, generates millions in revenue. The pressure to clean it up is immense, but the fear of causing an outage is even greater. So, how do you even begin to map this labyrinth? You start by creating a safe copy of the map. You don't explore the real maze, you explore a simulation. We do this by exporting the database schema. Using tools like pg_dump or miscall_dump with the schema-only flag, you can get a complete blueprint of the database structure without any of the data. This gives you a text file with every table, every column, every index, and every constraint. You can now use text searching tools like grep to hunt for patterns, find dependencies, and start to piece together the puzzle without ever touching the live system. Once you have your map, you start the real work documentation. This is the most important and often most neglected part of surviving the labyrinth. You create a data dictionary. You use tools to generate an entity relationship diagram to visualize the connections. You adopt and enforce strict naming conventions for anything new you create. You become the historian, the cartographer, the one who finally brings order to the chaos. It's a slow, painstaking process, but every line of documentation you write is a torch that lights up a dark corner of the maze, ensuring that the next person who enters won't be walking in blind. You've mapped the labyrinth, but now you face a game of pure strength and strategy. The infrastructure tug-of-war. On one side of the rope, you have your trusty, familiar on-premise servers. You know them, you control them, they're right there in your server room. On the other side, you have the immense, powerful, and sometimes intimidating public cloud. AWS, Azure, Google Cloud. Management is pulling you towards the cloud, promising scalability and cost savings. Your gut is telling you to stick with what you know. This isn't just a technical decision, it's a battle for the soul of your infrastructure. The pull from the cloud is strong. They promise infinite scalability. Just click a button and get a more powerful database. They promise pay-as-you-go pricing, so you're not paying for idle servers. They promise managed services that handle patching, backups, and failover for you. It sounds like a dream, but then you look at the other side. With on-prem, you have complete control. You dictate the hardware, the network, the security. There are no surprise bills from a developer spinning up a massive instance for a test. You have predictable performance because you're not sharing resources with noisy neighbors. So how do you decide who wins this tug-of-war? You don't just pull blindly, you use data to anchor your position. This is where cloud CLI tools become your best friend. AWS, for example, has tools like the schema conversion tool and database migration service. You can run these tools against your on-prem database, and they will give you a detailed assessment report. They'll tell you exactly how much work it will be to migrate, what features are compatible, and what needs to be rewritten. This isn't about feelings or buzzwords. It's a concrete, data-driven analysis of the effort involved. Ultimately, the winner isn't cloud or on-prem. The winner is the strategy that best fits your needs. You have to evaluate all the factors. What are your security and compliance requirements? Do you need the elasticity of the cloud, or is your workload predictable? What is the total cost of ownership, including not just the server price, but also the staff time to manage it? By using assessment tools and creating a detailed evaluation matrix, you stop the tug-of-war. You're not just pulling on a rope, you're presenting a strategic plan. You're leading the decision, not being dragged by it. Here's a terrifying thought. You think you're safe. You've been diligently taking backups every single night. You have a folder filled with gigabytes of backup files, your safety net. But in this game, your safety net might be an illusion. A backup that has never been tested is not a backup. It's just a hope. The backup illusion is the game where you think you're prepared for disaster, only to find out when it's too late that your backups are corrupted, incomplete, or were never running in the first place. This is how careers end. The scenario is a nightmare. A junior admin accidentally drops the production table. The CEO is on the phone. Everyone looks at you. No problem, you say, trying to stay calm. I'll just restore from last night's backup. You go to your backup file, you run the restore command, and then you see the error message that makes your blood run cold. Or worse, the restore finishes, but the table is still empty because the backup job was misconfigured and was skipping that table all along. The illusion shatters and you realize you have nothing. This is why we have a mantra. A backup is only real if you can restore from it. You can't just trust the little green check mark in your backup software. You have to prove it. And the way we prove it is by actually doing it. I'm going to show you the commands right now. For PostgreSQL, it's For MySQL, you need to take your backup file, spin up a temporary separate server, and run the restore command. You need to see the data appear with your own eyes. This isn't something you do once, it's something you have to do regularly. The only way to win this game consistently is through automation. You need to build a system that automatically takes a backup, spins up a temporary instance, restores the backup to it, and then runs a series of validation checks to programmatically verify that the backup is valid. Then, it tears the whole thing down. This entire process should run every single day, and it should alert you the moment a validation fails. This turns hope into certainty. You're not playing a game of chance anymore. You're running a disciplined fire drill every single night. You've scaled your application. To handle all the traffic, you're not using just one database anymore. You have a primary database for writes and a bunch of read replicas for reads. It looks perfect on your architecture diagram, a beautiful distributed system. But you've just stepped into the next game, the replica mirage. From a distance, the replica looks like a perfect, up-to-the-second copy of the primary. But when you get closer, you realize it's an illusion. It's lagging behind, showing stale, outdated data. This is incredibly dangerous. Imagine this scenario. A user changes their password on your website. The change is written to the primary database instantly. Then, the user immediately tries to log in. The login attempt is routed to a read replica to save load on the primary. But the replica is lagging by 10 seconds. The password change hasn't arrived yet. The login fails. The user tries again, fails again. They think their new password didn't work, so they try their old one. That also fails. Now they're confused, frustrated, and about to file a support ticket, all because of a few seconds of replication lag. This mirage can cause chaos in all sorts of ways. In an e-commerce system, a product might show as in stock on a replica, but it actually sold out on the primary database 2 minutes ago. A customer buys it, gets a confirmation email, and then you have to send them another email an hour later saying, "Sorry, we're out of stock." You've just created a terrible customer experience. Replication lag isn't just a technical metric, it has real-world consequences that can erode user trust and damage your brand. You have to be able to see through the mirage. So how do you know if you're looking at a mirage or the real thing? You have to measure the lag. In PostgreSQL, you can run a query like to see exactly how far behind a replica is. In MySQL, you can check in the output, but you can't just check it manually. This metric, replication lag, needs to be one of the most important things you monitor. You feed this data into your monitoring system and set up aggressive alerts. If lag goes above, say, 5 seconds, your on-call engineer gets a page. This turns the invisible mirage into a concrete number you can manage and control. The next game isn't about speed or uptime, it's about rules. Thousands of them. Welcome to the compliance minefield. You're walking through a field littered with hidden explosives like GDPR, HIPAA, and SOX. One wrong step, like logging a user's credit card number by mistake or failing to prove who accessed sensitive data. And boom. You're facing massive fines, legal action, and a complete loss of customer trust. The goal of this game isn't just to keep the database running, it's to prove you're running it responsibly. The scariest part of this game is the audit. An auditor comes to you and asks for a report of every single person who has accessed a specific patient's health record in the last 6 months. Or they want to see proof that you are encrypting all personally identifiable information, both in transit and at rest. If you can't produce these reports, you fail. It doesn't matter if you were doing the right thing. If you can't prove it, you're guilty. Many DBAs live in constant fear of this, scrambling to piece together evidence from scattered logs when the auditors come knocking. You can't win this game by being reactive. You have to build compliance into the very architecture of your database from day one. Let's take that audit request. Instead of digging through logs, you should have an audit trail built in. Using tools like Pgaudit for PostgreSQL, you can configure the database to automatically log every single query that touches a table you've marked as sensitive. When the auditor asks, you don't panic. You just run a simple query against your audit log table and export the report. You've turned a week-long scramble into a 5-minute task. This proactive mindset applies to everything. You don't just hope developers are handling sensitive data correctly, you enforce it. You use column-level encryption for sensitive fields. You implement robust role-based access control so that developers can't even see production data they don't need to. You use tools that scan your database for personally identifiable information and alert you if it shows up in unexpected places. By building these guardrails, you're no longer tiptoeing through a minefield. You've built a safe, paved road right through the middle of it, with clear signs and strong fences to keep everyone safe. You've made it to the final game. It's not about immediate disaster, but about the long-term survival of our planet. Welcome to the Green Mandate. For years, we in tech have focused on performance and cost, building massive data centers that consume enormous amounts of power. But now, the world is changing. Companies, customers, and employees are demanding that we consider our environmental impact. This game is about making our digital infrastructure sustainable. It's about being a responsible global citizen, not just a good DBA. The problem is massive. Data centers are projected to consume up to 8% of the world's electricity in the coming years. Every inefficient query, every over-provisioned server, every byte of data we store unnecessarily contributes to this. It's easy to ignore because it's invisible. You don't see the smokestacks when you run a query, but the cost is real, measured in carbon emissions and environmental strain. The challenge for us is to find ways to reduce this footprint without sacrificing the performance and reliability we've worked so hard to achieve. So, what can we actually do? It starts with data. So much of the data we store is junk. Old logs, temporary tables that were never deleted, user data from a decade ago. We need to implement data archiving and retention policies. Data that isn't needed for daily operations should be moved from expensive, power-hungry primary storage to cheaper, more energy-efficient cold storage solutions like Amazon S3 Glacier. This not only saves money, but also significantly reduces the energy footprint of your database. It's a digital cleanup for a greener planet. Beyond data, we need to think about our hardware and providers. If you're on-prem, are you using the most energy-efficient servers? If you're in the cloud, are you choosing a provider that is committed to renewable energy? Cloud providers like Google, AWS, and Azure publish their sustainability reports. You can choose to run your workloads in regions that are powered by wind, solar, or hydro. You can also right-size your instances, ensuring you're not paying for and powering CPU and RAM that you aren't even using. Winning this game means making conscious, eco-friendly choices in every part of your infrastructure. We made it through all 7 games. From rogue queries to legacy labyrinths, from the tug-of-war of infrastructure to the illusion of backups, we've seen that database administration isn't about surviving one dramatic event. It's about navigating a constant stream of challenges with foresight, precision, and a touch of humor. It's not a single terrifying game of red light, green light. It's a marathon of strategy, discipline, and continuous learning. The real prize isn't a pile of cash. It's a stable, secure, and efficient system that powers the world around us. Every command you optimize, every backup you validate, and every piece of documentation you write strengthens the foundation of modern technology. You're not just managing data, you're safeguarding the backbone of your organization. You are the guardian of your company's most valuable asset. The skills we talked about today, proactive monitoring, diligent documentation, strategic planning, and automated validation, are what separate the survivors from the masters. Embrace these challenges, because overcoming them is what makes this job so incredibly rewarding. You have the power to bring order to chaos. I poured a ton of real-world experience into this video, and I really hope it helps you navigate your own DBA challenges. If you found this video helpful, give it a thumbs up, drop your thoughts or your own DBA horror stories in the comments, and most importantly, subscribe to the channel for more practical tips and tutorials. Your support helps us keep creating valuable content just like this, and it tells me you want to see more. Thanks for watching, and go win your game.